Our code for today is one bad programmer can easily create 2 new jobs in a year. So keep doing a bad job, it gives us more jobs. Okay, so today's recap, I'll handle the recap. Today's lesson is called functional programming. And before that, let's first talk about functions. Okay. So before that, what is a non-functional approach? So let's say you have const course name, string. Oh, it's so harder to type here. Const course ID, string, say 142. And then let's say we log that out. Course ID plus course name. Should be other way around. There you go. So that's a non-functional approach to concatenate string. If you want to go to the functional approach, you can just create, hey, hello. Want to sit in? Yeah, first you create use the function keyword, and then you can optionally define your function name. Afterwards, you create an open parentheses, so you can put your parameters and data types. So you put course ID and put a type safe called string. Go ahead.
Can I just
Go ahead.
Yes. Thank you. First, another good news, Jake, he passed the exam. So let's give a big hand.
My man.
Another sad news. I want everybody also to forget about, I don't know whether it's easy to come back or not. I was just informed because I could not see myself. Yes. I don't know the exact reason, but I think it's a bit far away. Still, it's not finalized about. I'm hoping if we know him, maybe we can convince him, please convince him, come back. Okay? But that's easy to see. Okay. Now, also we have a good news too. Now, Impure is taking another role because of the this time we are lucky. Usually we may not have many lady students who are studying computer science. We have a lady student. I joined this one, and this morning also joined another. Did you stand up?
Oh, I didn't know that.
Come here.
I didn't know that. Awesome.
But still, also for them, they need a paper processing. So they are observing this one and then ISO, you will guide them, you will show what they are doing. Okay, introduce yourself. What is your background? What are you doing here? Yes.
My name is Amita Vaidyanathan and I'm from India. I did my bachelor's in computer science and I worked in corporation for 1 years. And now I'm studying master's in computer science at the University of Seattle. I'm excited to be a part of this team. I'm looking forward to it.
Okay, thank you. Welcome. Yeah. Also today I have a wonderful time. And now we have a 3 weeks. Everybody let's finish this one. We made a 50%. So students who pass the exam, please focus on programming. Okay, really enjoy the program. I'm sorry, in cyberspace, there is no American. So we cannot speak only one language. You have to speak a multiple language. So please learn TypeScript a lot, and then move into the Python. Also, I appreciate that this guy, I heard of that. Maybe students he's doing a pretty good job. Also, someday you are saying, hey, Sam, he's better than you. I really want to listen to that. Okay? Yes. Go ahead.
Okay, thank you, Sam. Okay, going back, we first shown you a non-functional approach. We had 2 variables, we concatenate them and output them to the console log. Now we'll go with how do you do a functional approach. One of the first steps is you define a function. You need to use a function keyword and you define a name, in this case, make course, it's optional. And then open parentheses, you define the arguments. And then you also put a type safe as a string. After the parentheses, you can define only in TypeScript what return type you're expecting. Again, a string. And then the function body opens up with a braces. And then now you can say, oh, return course ID plus, let's say, 142. No. Yes. It should be the other way around. So we log that out. Course ID. Course name, actually. Sorry. Course ID. Yep. And it should be the same. So if I change this, it changes. Okay. So also, functions are called first-class citizens. It just means that they can do anything what others can do, because functions are basically objects. It's just another what they define functions is. They're called first-class citizens. Okay. Also, let's try to refactor this one. Now let's try to make a function expression. Function expression just means that you don't have a function name and you assign a variable. Assign that function to a variable. Let's say make course. Then let's see, we change this. Still the same. Okay, the difference is, again, we don't have a function name and we assign that to a variable. Next is anonymous function. So with anonymous function, you remove the function keyword. You also use the arrowhead operator. Let's try that again. So there you go. So anonymous function, you don't have a function name and you don't have the function keyword, and you put an arrowhead operator. Okay. Optional parameters. Basically, you can just have a question mark here. See if it's empty. Undefined, which is the expected because you didn't put any. Also, default one. Can assign this to, let's say, 30. So remove that. Yes, 130. Okay. If I put something there, it should overwrite that. There you go. So we've done a quick recap of what functions are. And now let's move on to other types of functions. Okay. Again, going back, functions, we can assign them to variables. Also, they can be added to objects. So let's create an object. So you have type. Let's create a custom typing. Say this is M string, and we want the return type to be void. Okay. And then now we define the declare the variable object. And then let's say your object uses the custom typing, my object. Go ahead. Go ahead. So again, object is one of the keywords you have to remember. It's key value pairing, and it's one of another kind of data structure when you can store data. Correct. So inside an object, you can store a key and a number, right? A key and a string, a key and an array, another object. So you can basically store functions, whatever you want. Okay, it's an unordered list though. It's the contrast of arrays. Arrays is like there's an order, right? Okay, we'll keep using objects and arrays. So it's just another data structure. Don't worry, we'll keep using objects and you'll get the hang of it. Okay, that's an object. Again, object, you need the braces. And then with the braces now, we can, let's say, put this one. And let's say we add the console.log, log out M. And then let's just close that. And then we'll call object.f. And let's put a parameter. See, there you go. So again, line 1 to 3 is just we're creating a custom type, and we created a variable named myObject, and then we say that, oh, the function should get a parameter that is a string. Here we go, and it should output a void, which console.log doesn't return any. Okay. Next thing is line number 5. You have a variable named object, and it uses the type safe of our custom type, myObject. And inside of that, inside of our object, we have this function. Okay, our function just logs out to the console. Okay, to call that, you need to call the variable object, and because it's nested, you use the dot notation, and you call f, which is this one. And then now, because you need a parameter, you put a string. Okay. Also, you can use arrays to store your functions. So again, with arrays, you start with let's start doing our custom type again. So we have an array, and we want our array type to only include a function that gets a string and returns a void. Okay. Next is, let's declare an array. And then in that array, we use the custom typing, myArray. And then myArray is, again, let's create that function. Let's use an arrowhead. And then console.log. And then let's access that. It's 0. And then as a parameter, s. We also need to do this. Nope. Okay, this one. Okay. Usually an array looks like this, right? If you remember, inside of the square brackets, we just put function. And now to call that. So again, line number 1. We create a custom type called myArray, and basically it says that we want that custom type to array to only have a function as a parameter, and in that function, it includes it should only get a string parameter and output a void. Okay. Next is we created a variable named array and used the custom type myArray, and then now inside of the array index 0, we put this anonymous function, also called as lambda function, anonymous function, which takes a parameter, this is the m, and then executes this API, console.log, that outputs the input, okay? And then now in line number 7, we call the variable, the array variable, and then now we access the index element, index 0, and then we pass a parameter. Test number 2, let's see. There you go. So again, it goes back to when we said functions are also values. Functions, you can put them in variables. Functions, you can put them in objects. Functions, you can put them in arrays. Functions, you can put them in functions. Okay? And that's where we go to higher order functions. Okay? Huh?
So on line 7, you actually assign index 0 as to, or just telling it that instance. So if you call index 0 again, it might be.
Again, when you call index 0 again on line, yep. Oh, it will complain. Because again, now we're using the TypeScript that it says, oh, you are required to pass in a string for your function parameter. But if it's JavaScript, it will just allow it. Okay. again, it says here expected 1 arguments, but got 0. And now it refers to this type safety that we given. Okay, we're now going deeper. Don't worry, I checked it. Towards the end, it will be clearer and easier to understand what higher order functions are. For now, just bear with it. Okay, so let's go back to the make course and course name. And it's a string. And then let's have the course ID again as a string. And then because it's a function within a function, we're going to expect a return, not a string yet, but the function. Okay. Now inside this make course function, we now create a return type. We want to return a function, so therefore we create another function. Is it case sensitive, the keyword? Yes, the type safe keyword. Yes. Let's make this bigger for now. We have longer code. And then let's create another function. This time we don't have a name for the function, because that's allowed. Actually, we should remove this because we're trying to simulate. Okay. And then this one, in this new function, we want to pass a parameter string, a course ID, a numeric string, and then output a string. And then we create another function body for that one. And then now what we want to return is, hey, I want you to return the course name first. Yep, course name plus course ID. There you go. Recap before we log this out or create another variable. We have a function make course, and make course needs an input, which the parameter would be named course name. It is a string, and the expected return for that function is another function. Inside that function, you would return another function. And this another function that has no name, it requires a parameter named course ID, and the data type is a string. And it would return a string, okay? And inside of that no name function, it will return the course name plus the course ID. So now let's create first a variable called CS course. And in this CS course variable, we do a make course. We call that function. We put a parameter, and that parameter is CS. So now we satisfy the first one, that it has a parameter, but we still need another one. So because now the make course function is assigned to the variable, we can now use the variable CS course, right? So we can use CS course. Then now we put another parameter, which is, let's say, the 142. Console.log CS course. Actually, let's grab this one. There you go. So what happened here, line 7, we declared the variable CS course, and we assign the function make course. We give it a parameter named CS. And then now in number 9, we use the variable and give it another input and give the numeric string 142. So it was now in here. Okay. Next, let's do another example. This one is a number. That's weird. It's double function x number, and then we output a number. And in that number, we want the x to return x times 2. Okay, so we have a variable named double, and we created a function that needs a number that returns a number, and in that function body we return x times 2. Okay. Now let's say we want to use another variable, because you can assign, right? What does it say? 4 is not assignable to the type parameter, because I think this time is should put a function. Nope. Let me quickly check. What is this question mark? Catch. Yep. So now we do whammy 2, and let's because it's double whammy. Let's see. Let's try to log that out first. Got 8. And then because my guide here is not really looking so good, it has special characters. So for a while, so it was this one. Why was it complaining though? Oh, it's the same. So now let's do this console log. Let's see. Grab this one. Log. Here. Becomes 4. Again, what happened here is we just showed you another case of because the function we assigned to the variable double. So again, a variable can be assigned to another variable. And then that's what we just did. And now we use that variable and put a parameter, numeric, a number, okay? Okay, let's do something a bit fun. Before we use the higher order function filter method, let's do it in the for loop way. So let's create a, let's do an object. And let's say I have a variable named humanoids, and in that humanoids, I should get a string and a species, and then a string. And then they would be an array. So it means just by this type safe, my variable should be an array. What does my array include? Objects, the braces. So again, another way to declare an array, let's say we just want a number, we do that. But if you want an object, there you go. So now this is an array. So we open with square brackets. In that square brackets, now we can put our objects. Let's say our first name is Rhett. And then species is Romulan. Okay? Let's populate that. To Volk and Vulcan. And we have Spock. And then we have a Worf, which is a Klingon. Who knows how to do Klingon? I don't know. I don't know how to speak Klingon. And the Borg Queen, which is a Borg. Okay, we now have an array of objects. And what we do now is, let's say we want an array that we only get the Vulcan species. So let's name a new array. Let's just call that name Vulcans. Right now it's empty. And what do we want inside of it? We want the same thing, right? The same structure. So we can just have the same one. Let's have name, string, species, string, and then square brackets, because it's an array. Okay, right now it's empty, so just do that. Empty square brackets. Now let's take advantage of a for loop. Let I equals, this is your initialization, and then I less than the length of the array humanoids. This is an API. So this is your loop condition. Every time it loops, if it's fine, if it's true, it's to execute the code block. If it's not, exit the code block. Okay. Next is we have the incrementer, and we open the code block. So how do we just filter it with just the Vulkan? So we know that we have an empty array and we only want to put Vulkan species, right? So let's create a condition. If the humanoids, okay, and then because we're gonna iterate over that, we'll use the counter I. So with the I, it will do this one, this one. So it's gonna be this one, then this one, and this one, this one, then this one. Okay, that's your I. But now you have access to the objects, but you want access to the species. So you do a, let's say, dot notation, species. And what do we want? We want Vulkan, because we want Spock, right? So if we found a Vulkan species, we now capture them and imprison them in an array. We push them into the array. Let's see what our Vulkans, how many Vulkans we got. We log out that array. We go back here, refresh, and we see 2 objects that has Tuvok and Spock. So now a question for this is, wow, that's a lot of setup. You have to do this all the time. Have a for loop, enter higher order functions. Okay, higher order functions would make your life easier. So let's try to remove this for loop. Okay, and what else? Say we still need this empty array, right? But now we want to immediately use the higher order functions filter. So now this one would have, let's say, the Vulkan array would be initialized already. We'll use the humanoids array. And in the humanoids array, let's access the filter method or API. This is a higher order function. Why? Because now this filter API, it requires a function as a parameter. Okay, so you open that with that one. Requires a function, do that. And let's say in your functions, you would have the humanoids and you would grab the species as your parameter. And in the species, it's a string. Okay, and then what does this return? Boolean. Next is we define return humanoid that species equals Vulkan, because we want to capture Vulkan. Let's see, any function humanoid species boolean blah blah blah. Oh, what's that one? Open. Okay. Let's see if we still get the same Vulkan. Let's try to change that. How about, let's check if it's good. Board. Should get the board queen. So capture the board queen. So this is one of the like superpowers of higher order functions. You just pass the parameter and that's it. Okay, go ahead. I'll give more examples of this actually. No, it requires a function parameter. So it could be maybe in JavaScript, maybe it will allow you, but it will filter nothing. It might just return the same array. It's like when you use the slice API of the array, if you don't put anything, it just is the same array. Okay. Another thing that we can do is we can refactor this code line 9 to 12 and decouple them. So what we can do about that is, let's say we have a, we still have this. Let's define, let's remove this first now. Okay. Let's create a variable named let is Vulkan. So by the variable naming alone, you know that it's asking for a Boolean value. Okay. You have to remember it's also a good skill to have a good naming of your variables so they can easily understand it right from the bat. So let's take a humanoid, and then in that humanoid we want the species. That's a string. And then you all know already it's going to return a Boolean, should be afterward. Okay. Return humanoid dot species equals, we can do Vulkan again. So what we've done is not yet the filter function. We created a function, no name function, and assigned it to a variable name is Vulkan. That function gets a an array that has an object, which has a string, okay, and returns a Boolean. Because if you see return humanoids.species is equal to Vulkan, it will only return true or false. Okay, now let's use the filter function again. Let Vulkans, we want to create that array, and that Vulkans can have humanoids.filter and just put this Vulkan. It's more readable now. So when you decouple it, you really understand it piece by piece. And once you get that core concept, you can mash everything together. Okay? Now let's try to refresh that, and hopefully it's Vulkan now. It's Vulkan. Great. Next, let's do the map method. A better practice. Towards the end, I'll show you a code decoupled, and then I'll show you a code that's the better practice. So every, go up. So like every after the parentheses, don't do the semicolon yet. They keep putting filter. And you see another one, invoke another API method, let's say map. And then when you're end with everything, you put the semicolon. So it's nested. Okay. Next is we have the map method. Let's go away from this one. And let's do a simple one. Let's have an array of 1. And we have a 1, 2, 3. And then let's say we have a array of cons R2. And let's say it's a, let's put the type save. Okay, array number 2 would be array 1 that map. Map functions just goes over each element in the array. Okay, in the map function, it also requires a function. That's why it's a higher order function. So create a function without a name, and it will pass a parameter named item. Okay, and let's put type safe again, sorry. So array 2, we want it to be a number array again. And then in the array map function, the item should be a number, and the return should be a number. Okay, now what we want to do is just an easy way, return item times 2. Right from this code block, you already kind of have an idea that that it will just multiply everything by 2, which is correct. So if we log that out, that here, oops, wrong click. So the 1, 2, 3 becomes 2, 4, 6. Okay, let's go over this again. In line number 2, we created a variable named R2, ARR2, and the data type that we want is a numbers array. And in the numbers array, we assign a an array, which is you grab array 1, and then you invoke an API of an array, which is a map. And a map function requires a function. So we created a function in that as a parameter. And in the function, you have a parameter that requires a number and spits out a number. And then inside of the function, you just want the item, each item, to be multiplied by 2. Okay? So now, again, we'll use the beauty of our functions. Just remove the function name and put this here. So it's the same. 3 times 3. Okay. Reduce method, on the other hand, is when you try to accumulate stuff and reduce them into 1. So if you have an array of numbers, you can just have 1 number afterwards. So let's create, again, let's use the same example. Instead of map, let's do the reduce. And in the reduce, we create a function again. Let's do the function here first. And in that function, again, reduce is also a higher order function. Okay? And then it requires a function, but that function should have 2 parameters. So instead of just number, let's make this parameter name longer so it's clear. The first parameter should be your accumulator, or the total, or the sum, accumulator. And the second parameter should be the, let's say, current value. It's also a number. Let me just put this down here. Okay, and then we return, and now you see it's complaining. We check. Number is not assignable to type numbers array. So now, just with the type safe, it already knows that reduce function just returns a number. So it helps us right away that, oh, not even checking the API, I know that it returns just a number, because there you go. Now this one doesn't complain. Yep. And then now, what we return now is the accumulator plus the current value. Okay, so the expected number that we should have is 3136, right? Sure. So just one number. Okay, let's do a combination of these 3. I'll start with a big code, the coupled, and I'll make it refactor, and then refactor, and then refactor again. Let's make this relatable to everyone. So let's do a years, and it's a numbers array. And in the numbers array, we'd have 1, 2, 3, 4, 5, 6. I missed 4, 5, 6, 7. That should be fine. Okay. So let's say we want to have to do a calculation of the dog years. Okay. I'm just gonna use a rough estimate. So first, we wanna use the years variable. Because it's an array, we do have access to the map function. And in that map function, it requires a function. And inside of that function, it should have a parameter, and that's a number. And that function inside of it should also output a number. Okay, now we can define the body of the map function. So what do we want? So we want to return, to convert normal human years to dog years. So we just return the item and multiply it by 7, right? And then this one should also have a number years map functions item number. What's this called? Oh, expected comma. Expected comma. Can someone see my typo here? Where's my typo? Oh. Let's see. Yeah, I have a typo. ellipsis before function. Let's see, map, open up the map. You have functions, you have item, you have number, you have number. I think I closed this wrong. There you go. So that's a typo. Okay, let's log that out. Have the dog ears. There you go. We just multiplied everything by 7. Have questions? Go ahead. Okay, map basically just is a higher order function. It's an API of an array. So if you have an array, you can do a dot, then call the map. And then the map functions requires a function. Okay, your function that you put in the map function should include 2 parameters. Okay, I know, sorry, let's reduce. 1 parameter. So map is just, it's just a for loop. Underneath the hood, it could be, I think it's just a for loop. Iterates over each element. Instead of creating this for I, blah, 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 right? Just do the map. Okay. So the map works, and let's say, yeah, let's say we want to only get the old dogs because they're sad. So let's do a numbers array. We declare the variable old dogs with a numbers array type safe. And in that type safe, let's say the dog years, let's do a filter. So again, dog years is an array. So you have an access to the filter method. The filter method is a higher order function. It requires a function that needs a parameter, a number, and then spits out a Boolean. That's why I keep closing that one prematurely. Okay, close this with semicolon. So what do you think is in just a subjective opinion, what is an old dog?
Old dog.
In dog years. Or else we'll just get the same array if you just said 2 years. Oh no, now I'm making everything sad. Sure, okay. Okay. So let's return all dogs that's have dog years that are greater than 15. So greater than 15. So now the array got filtered. The new array got filtered. We don't have the 7 and 14 anymore. So that's how you do a filter. And what if we say, okay, let me sum up all of the old dogs, okay? So just create an array, a new variable named sum of old dogs, or make it shorter, sum of dog age, okay? And let's say because it's a reduce function, it returns just 1 number. So the type safe should be number and not number bracket, okay? And let's access the old dogs. Old dogs is an array, and when we hit the dot notation, you would have access to your APIs, and one of it is reduce. Reduce is a higher order function. A higher order function requires a function as a parameter. So you have a function, and inside that function, it should has 2 parameters. Let's have the accumulator. Make it short, just act, and then number. And then let's say the current value. Let's make it short, cur, Stephen Curry. And then returns a number as well. Okay, how do we reduce this? This is just a sum. We add the first parameter with the second parameter. Okay, console.log sum dog age. Boom. 175. Can someone quickly confirm if it's Nah, kidding. No. Okay, first refactor that we can do is we can change the no-name function to an arrowhead function. So right now we're trying just to reduce code. Okay, change that. Put that here. Move that. Put that here. Move that. And I should have the same output. Let me just change this. Let's say 30. Okay. So another way to refactor it is the question a while ago, nesting everything. Let's see. Let's just check the JavaScript code. Okay, looks fine. Looks the same. Okay, now let's do some nesting. So when we refactor, I don't really need to write everything again. So let's just grab this one, some dog age. We're gonna do a nest, and we're gonna use the map, filter, and reduce. So the ending is reduced. So the ending output should be a number. Okay. Access the years, and I don't have to do that. Let's just use this one. Put that here. Delete this one. Okay. Now usually you end it with semicolon. You don't do that now because you want to keep accessing. So now you use the filter. Grab that here. Now I can remove this. And then now I can use the reduce. Grab that, put that here. End it with a semicolon. Remove unnecessary code. Beautiful. It is beautiful, right? So again, because let's go over this. Line number 2 says I declared a variable some dog age, and that would return a number, right? And I would assign first, I would use the years array, and I would use a map function. So you already know that the map functions just require, you need a function, which we define this one. This is a function. This is the function body, remember? We have the parameter, return type, function body. And when you end that with the parentheses, and it resolves, if this resolves, right, it's an array. So because it's an array, you also have access. It's still an array, so you have access to the APIs of the higher order functions, whatever. And then now you do the filter, and then until this one, it still returns an array. Hence, you can reduce. That's why if I want to do another, let's say, filter here, it won't work. Filter does not exist on type number because reduce already returned number, right? But this one, we can interchange. Let's do some, let's see, how about this one? We can do this, I think. Should be no problem. Yep. So we've just done filter, then map, and then reduce. Should be fine because filter and map are all returns an array. That's why I can interchange them. But reduce of empty array with no initial value at array.reduce. Okay, looks like I broke it. So never mind. Correct, good catch. So let's put it back. What if we do this one? Let's see, 4. Nice. How about greater than 6 only? It should be 1. Okay, what happened here is we filtered every item and only return if it's greater than 6. So we have an array that only has 7, and 7 times 7 is 49. Okay, and there's nothing to accumulate, so that's it. Okay. Questions before I move to the other concepts of functional programming? So this is already functional programming. There's a lot. These are the commonly used. That's why in every book you see or online resource, you will always see, there's the map, oh, there's a filter, oh, there's the sorts. Yes, correct. But sort is not a higher order function, I believe.
Sort. So what happens if you take everything out below line 6? After
Sure. It's the same, but it
they reduce it.
turns the array.
But I mean, okay, all I did is take it from being an array to being a single number.
Yeah, and then now you would see this is not wrong because it needs an array. Yeah, but again, and because it just gave us an compile time error, you can still compile it if you want, and it became JavaScript, and it did not save us from a runtime error, something like that. Because let's say I just want one number, and it now returns me an array with index 0 with length of 1. So again, it helps you with compilation, but it would still push through, and it would still execute.
It executes as
A JavaScript code.
it's expected, but that's based on what you have. That's a valid result.
So just to fix this, because the last one is an array, so there you go. It doesn't complain anymore. Okay? Oh. Woof, woof. Okay. So the other concepts of, let's see. Anyone still have a question? Oh my God, it's already the 10th? I'm just halfway. Okay, let's do a break time. But I need to continue on because this is just one concept, but don't worry. The other one is just like what is a pure function, what is immutability, and I will just show you simple use cases and not just functions anymore. Okay, take a break. We go back and let's continue with the lecture and then concept test. Okay, be back by how long usually should break? Well, I guess 10 minutes should be fine because lecture and then we'll have concept test. Okay, I expect you to be back by 10:10. 10:10, everyone. 10:10. Okay, let's restart.
Do it.
Let's do it. Okay, so one of the concepts of higher order functions, functional programming, is immutability. Because I've heard you guys talking about it, and it's true. Higher order functions fits one of the concepts of immutability. Don't mutate the existing array, you create a new array. So if you invoke the filter or map function, you basically create a new one. Okay, so now with the concept of immutability, let's start with the variable of cons. Just with this one, using cons, you can't reassign a new value to your variable. That's immutability. Okay. In objects, we can, let's say, create a red object. And in that red object, we have a color, let's say red. And let's create another object, yellow object. And we have the color, and that's a yellow. Oops, okay. And then let's do a console log first for both of them. Okay, we have red and yellow. So in objects, you also have an object API called assign, so that instead of manipulating the existing object, you create a new object. So let's say we want to create a yellow object again. But this time, we kind of want to use the existing object, let's say the red object. So again, let's define yellow object. And then in that yellow object, we use the object.assign method. And in that method, we put a, I think the syntax is, yes, braces, braces, yeah. And inside of braces, another parameter would be the object that you want. And then let's say you want to have a different key value pairing, say yellow. Then it should work. Yes, I should have the same one. So let's say green, should be that one. So notice that, let's say if we log out red object again, should not change it. Okay, that's immutability. Okay, another way to enforce this immutability is in arrays. In arrays, we can access the concat API. So let's say we have a const A, and then we have 1, 2. Let's do a number of the array. And then let's do a const B. And const B, what we want is, we want the array A to, let's say, concatenate with the value 3. Okay. Console. Oh, sorry, this is also another. Okay, if you check A, right from the bat, we can already know that it won't mutate the array, even without console logging, because we use the const variable. Okay. Another way we can do is when we want to copy arrays, is we use the spread operator. So let's see, you have a const C, which is an array. And then you do a square bracket, dot, dot, and the array that you want to copy. It already shows us what arrays are available. Let's say B or A. Okay, let's do a C. Let's remove that. I should have 1 and 2. Okay. Again, this doesn't mutate the existing array. Yep. And we already talked about map functions, reduce functions. Another one that is in the paradigm of functional programming is the notion of pure functions and impure functions. So what are pure functions? Again, we talked about this last time already. Pure functions basically are functions that doesn't have a side effect, doesn't manipulate a global variable, it doesn't write to the console, doesn't write to a file, and whenever you have an input, you can compute and return the output the same every time. Should be the same every time. If you give it the same parameter, you should always get the same output. That's a pure function. Okay, let's see.
How to see inside? And multiple?
Yes. You should be able to. Let's try. You should be able to do that. Yep. So oh, let's try. Let's try that. Did it allow us? Operator cannot be applied to types number array. So we go back to the plus operator. The only thing that we can use the plus is if you had numbers, it can do an arithmetic operation of addition. we have a string, the plus sign becomes a concatenate for the strings. But turns out you can't use the plus operator for the number array or string array, basically arrays.
Could you try something?
Go ahead.
Could you try pushing to a array number?
You are not allowed, I believe. Let's see. Then should not do it. Ooh. You are able to. Oh.
I was wondering if they fixed it in TypeScript. I just did it in raw JavaScript.
So interestingly, you can still manipulate the array. So I guess cons is not really a good way for the arrays. I can go research for that deeper to check on that. Good question. Thank you for that. An example of a non-pure function. Again, if we're dependent on a global variable, this is a global variable, string CS. And then let's say we have a function. We go back to the make course. And in that function, we have the course ID string and output a string. In the function body, we return course name plus course ID. I don't even need to run this, but just by seeing the code, it's dependent on this global variable. So that's not a pure function. Because this one, the course name, is outside. So in short, let's say you have another developer or a friend who changed this, and now when you run your function, hey, it's not CS anymore. What happened? Right? It should be whatever you put as a parameter, let's say 142, it should be always the same, CS 142. Right? And now if some other people change it to, let's say, ISEC, it's become ISEC 142. It's like, hey, what happened? Should return the same one. I put the same parameter, right? But because it acts as a global, it's now dependent on something else, okay? Not that, again, just to be clear, not that it's bad, but we try to make pure functions as much as possible, but in a real world scenario, there's a lot of dependencies, okay? In purely changing objects, skip this. Purifying objects. Let's see. Oh, I guess we can just skip the objects then. Okay, let's do the muddiest point. Okay, are we trying to learn object-oriented or functional approaches to programming? Functional programming that focus on types. Okay, also I have a comment on this because even though we're taught a lot of object-oriented programming, I researched some of the videos of other developers. They're saying that functional programming is the way to go. It has less dependencies and better reuse. And again, because functional programming, you can avoid mutations, so you're always sure of what your result is. But with objects, you have like or object-oriented, you have inheritance. So you always don't know that you might end up changing a value somewhere, okay? Next is compose, trying to understand from the book. However, it's still pretty ambiguous to me. What is the meaning of composing? It's just trying to say how function is built, okay? First, we talk about inheritance. Inheritance basically says what they are, okay? And inheritance has this is-a relationship, okay? Let's say Clark is a person. So that's inheritance. I'm inheriting from, let's say, a person class, and I'm an object. Clark is a person, okay? Again, the problem now is it encourages you to predict the future and creates the taxonomy, categorization. Let's say we have a dog. A dog can, let's say, this should be an OOP, but let's do this quickly. I have a dog. that can bark and poop. Okay, fine. Now I have a robot that can fly and bark. How about if I want a robot dog? How can I inherit? Because one of the hardest part in OOP is you can't really have multiple inheritance. You can't inherit from, because if you inherit from robot, you get fly and bark, which is fine if you have a robot dog, I guess. But if you also inherit from the dog class, I don't think the robot dog can poop. So that's one of the problems, and hopefully we tackle this more tomorrow. Again, difference between queue and stack. Okay, last night I was already sleeping like 1 a.m. and I thought of a good example. But before that, let's talk about the queue. Queue is basically when you're lining up in McDonald's, getting that calories, awful calories. So what happens is people line up. So you NQ. When you enter the queue, you NQ. If you go out of the queue, you DQ. And it's first in, first out. Okay? Stacks, on the other hand, is basically you put something in the stack and it gets layered, gets layered, gets layered. And if you need the bottom one, you have to remove the top of the stack till you get to the bottom one. It's like pancakes. I don't know if you just put one fork on everything, but in that case, you should eat it one at a time, right? So yeah, so that's first in, but last out. So also another usually interesting challenges in data structures, they would say, oh, implement a queue using a stack, implement a stack using a queue. So I have this quick challenge that's usually asked, but I got this very good analogy. So if someone says implement a queue using 2 stacks, so it must still simulate a queue, but it must go through 1 and 2 stacks. So I thought of a good way. So let's say, you know Slinky, right? The Slinky toy that does like this. Let's say you have a horizontal Slinky. Now it's ordered as red, blue, and green. It should come out as red, blue, and green, right? But if you put the Slinky in the stack and it goes out, it reverts. It becomes green, blue, and red. But if you put that same Slinky to the second stack and you remove it, now it has the same order. It's red, blue, and green. So I just found out it's cool. So next, mapping was muddy for me. I guess we tackled it quite a lot. And if you have more questions, feel free to ask me afterwards. Is there any good examples of website script we can see for symbol functions, or do we need to go deeper into class for actual examples? So I tried to grab a simple one. Let's see. At first, I grabbed a bigger code. Oh, no, that's not the bigger code. I guess I deleted. Oh, this one is the easier code. Let's see. So this is just a basic HTML file that I have a body. Inside my body, I have a paragraph saying, hey, there's a button. And inside of it, I would have an input. And then in that input, I would filter the array. Okay? So I guess the better way is, let me simulate this first and explain the code later. Okay. I'll do that first. So the first thing you see, you click the button to get every element in the array that has a value, a specific number. So before that, please just focus on your eyes on the bottom, original array. So right now it's hard-coded. We do have array 32, 33, 12, and 40. And the index 0, 1, 2, 3. Okay? And then if I put a number here, it should filter the page, and it should output. And then if I click this button, it should multiply all integers by 2. So that's using the map function. So let's say I don't want, I want 18 and above. So I get this. 32, 33, 3, 32, and 40. And if I click this, I multiply all of them by 2. Okay? And if we go to the HTML file, because we already gone through this, you can see that focus first on this one. This is the original array. Let ages equals the number array. And in the for loop, no, this is just printing the original array. This one is this one, okay? So move on. So now we use the check adult age. So we pass a parameter, which is the array. And then if age is greater than or equal to the value, okay, print that out. So you can see in this function, line 32, it uses the filter because ages is an array. So you can still access the filter function. And this filter function requires another function, which we defined here. This is what I showed you guys earlier when we decompose. Instead of having the function inside the function, we create a function first. We put that in a variable. And then now that variable, we put it as a parameter to that higher order function. And it's possible because, again, the value of that variable is a function. So that's what happened. And the second function is just basically using the map function. And it's just saying, oh, every number is multiplied by 2. And now, because this is a get element by ID, it will look for, let's say this one. It will look for the ID demo, which is this one. Okay. And that inner HTML to write it out and then show this. Hence, that's what's happened. And then the second one is when someone click the button and then it will find this demo too. And we'll go to this one and write it out in HTML. Okay, I think that covered the Modius point. So higher order is function, just a function for a function. Higher order functions is a function within a function. Okay. Meta. It's like your soul. Go ahead. Oh, no, oh my God. You can return void. You can return void. Okay, let's do a quick recap to finish our lecture. We did functional programming with TypeScript and JavaScript. And hello, my name is Claire again. Programming, it's a programming paradigm. Okay, functional programming is a programming paradigm. It's a coding style as well. Okay. Also, it promotes less bugs because, again, less dependencies. You know the exact output if you give the same input all the time. It's easier to reason about if someone says, hey, what is this function? What does this do? And you can answer readily that, hey, this does this. End of conversation. Okay. Again, less time. Remember that functions are values. That's why we can assign them to a variable. And again, not all programming language can do this. Meaning, create a function and you assign them to a variable. Not all can do that. And compositions, so higher order functions are good for this concept called composition. Basically, composition allows us to compose smaller functions to create a bigger function. Okay, kind of like what we did in the higher order function. There's a lot of small functions to create one function to just check the old dog's years or old dogs. We did the example of non-functional. Just have two variables you add in. Example of functional, you use a function. Pure functions produces no side effects. Don't do a console.log out or write out to a file. No global variable dependency. Whatever you input, compute, turn on output should be the same. That's it. And then how to avoid side effects. Leave your input alone. Consider cloning your input. Hence, we did the immutability. We every time you invoke a higher order functions, it actually creates a new array. So we satisfy this, avoiding the side effects. And another thing is, don't make HTTP calls or write to this. And we do need this, but again, it's just for the concept, so to avoid side effects. Because if you create an HTTP call, if someone on that server changes their file or data, it definitely would change yours, okay? If a function has side effects, swapping out can break a program. So because your function is dependent, if someone says, can you refactor that function? And then you refactor it, become better, but because it was dependent to something that you didn't know, you eventually broke the code base. But if it's pure functions or does the functional programming approach, if you refactor that, nothing should happen. It should still be the same, like what we did when we compressed everything. So impure functions have inconsistent results, shallow copies that changes the original, because you do have some APIs that when you invoke it, it also changes the existing array. So let's say you have array A, array B, and you invoke an API that does a shallow copy, it might change the array A. Example of not pure, we already talked about that. It has a global variable. This one, a good example is when you're doing tax calculation, but your tax is a global variable. Example of pure and pure functions. Again, I asked someone, you almost never get pure functions, especially when refactoring code, because that's just the way it is. Side effects, making HTTP requests, mutating data, printing to a screen or console, DOM query manipulation, using the random API, definitely that's random, getting the current time, it changes all the time. Higher order functions, functions within functions, function that accept functions as arguments or return the function. We did that already, so we can skip that. Imperative versus declarative. So there's this another concept. Imperative approach is when you tell the machine that the steps it needs to get done. So meaning, an example of imperative approach is creating your own for loop. Declarative approach is when you tell the machine what you need to do and let it figure out the details. Okay, use the map function. Okay? You don't need to recreate what's already been done. Declarative for programming, oh, I said it. Avoid using loops. Use functional programming that constructs like map, reduce, and filter. Because your programs are more abstract and less focused on telling what the machine, each of the step of processing. So less mistakes as well, less bugs. Immutability, okay? Data never changes. Data is immutable. A variable can never be changed. To update its value, you create a new variable. Going back to higher order functions. So an example of immutability in higher order functions is they create a new array. We already talked about that. Okay. To end our session, let's again quickly recap what really happens in map and reduce. So map basically, let's say, goes through every element of the array list and it does some processing. Multiply, let's say in this case, I have integers. And in my map function, I want to chop them or whatever, prepare them. And this is what happens during map. And when reduce, you get one single item. And hence, you have a hamburger or lunch. So I guess at least, hopefully this hamburger would stick in your brains and not in your stomach to kind of visualize what's happening in map reduce and not get hungry. Okay? Okay, done. Thank you, and then let's do concept test for the attendance. And then that should be it for the morning. Concept test. I'll check with the other students.